So this is question 1A, and it's talking about spontaneous versus non-spontaneous reactions. So first, we'll go ahead and define spontaneous and non-spontaneous. And for the purposes of this video, I will be abbreviating spontaneous as S, non-spontaneous as NS, and equilibrium as E. So a spontaneous process is going to be a process that takes place automatically under the right conditions. So if you have water and you are trying to freeze water at 0 degrees Celsius, water should freeze spontaneously. Shouldn't have to do anything else. That's what happens. A non-spontaneous process is going to require the input of energy for the reaction to take place. So if you want water to freeze at 5 degrees Celsius, you're going to have to do something to make it freeze at 5 degrees Celsius, since water freezing is a non-spontaneous process at 0 degrees Celsius, and you want it to freeze higher than the freezing point. So that's going to require some input of energy, some alteration in the system to make that non-spontaneous process occur. So up at the top here, you'll notice that I've put a phase change diagram, and this will just help us when we're walking through kind of what's going on in all of these different processes. So we'll go ahead and start at the top left. Solid and liquid together at the melting point with no net freezing or melting. So the melting point, we're going to be over here. And you can see that this straight line B, where there's solid and liquid, that's when the ice is still melting into water and it's mixing together, so there's no real temperature change. So when solid and liquid are together at the melting point with no net freezing or melting, that's going to be an equilibrium system. Now, when you have liquid freezing above its freezing point, so water freezes at 0 degrees Celsius, and when you have water freezing at 5 degrees Celsius, that's not right. That's not non-spontaneous. So something's going on to make that a non-spontaneous process. Now, liquid freezing below its freezing point, that would absolutely be spontaneous. So if you have a liquid at negative 5 degrees Celsius, it should definitely be a spontaneous process to freeze. So liquid and gas together at the boiling point with no net condensation or vaporization. So again, here we are at that horizontal line, the spot where you have both liquid and gas. So that's going to be an equilibrium system. The next one, liquid vaporizing below its boiling point. So you have a liquid turning to a gas below its boiling point. So water boils at 100 degrees Celsius. If the water starts boiling at 95 degrees Celsius, something's going on. So that's going to be a non-spontaneous process. A solid melting above its melting point. So if the melting point is 0 degrees Celsius and the solid is definitely melting at 10 degrees Celsius, it's a good thing. That should happen. That's going to be spontaneous. Gas condensing above its condensation point. So gas shouldn't be really turning back to a liquid above its condensation point. You would hate for gas to be turning back to a liquid at 105 degrees Celsius when it should be a gas at 100 degrees Celsius. So something must be going on here to make this gas back into a liquid above its condensation point. So that's going to be non-spontaneous. A solid melting below its melting point. So if the melting point is 0 degrees Celsius and you have a solid melting at negative 5 degrees Celsius, that's not good. Something is going on there. Liquid freezing below its freezing point. So if you have a liquid and it's supposed to freeze at 0 degrees Celsius and it's freezing at negative 5 degrees Celsius, that's good. It's doing what it's supposed to. That's spontaneous. Under the right conditions, when it's supposed to freeze, it is freezing. Gas condensing below its condensation point. So if a gas is condensing and turning back into a liquid below the point where it's supposed to be condensating, that's good. It's supposed to be turning back to a liquid at a certain point, and if it happens below that point, that's also spontaneous. And the last one, liquid vaporizing above its boiling point. Vaporization is the turning of a liquid to a gas. Should happen at the boiling point. If it happens above its boiling point, the reaction is occurring spontaneously at the right conditions. That is a spontaneous process.